have discussions for experiment 9, some reactions of copper. The purpose of this reaction is basically to learn techniques as you're going from one reaction to another reactions of copper. And we also are going to reinforce the law for conservation of the mass. So basically, in this reaction, when you watch the video, you will see that we are starting with specific amount of copper. Let's say we start with 0.4 or 0.5 grams of copper. And we are going to dissolve the copper in nitric acid. Nitric acid is a very strong acid. It can dissolve the copper because copper is very unreactive metal. So it would, first reaction, dissolve the copper in nitric acid, and with the oxygen from the air, we are going to get the copper nitrate, water, and nitrogen dioxide, which is like a brown color and is a toxic gas. So that's one reaction. It needs to be done in the fume-hood because of this toxic gas. You add water to it to dilute, to make sure all the gas is gone. Then you would add sodium hydroxide. When you add sodium hydroxide with copper nitrate is going to have double displacement reaction. Remember from experiment 17, we have double displacement. So we get metal from one compound goes with the non-metal from second compound, and then metal from the second compound goes with the non-metal from first compound. So we get copper hydroxide and sodium nitrate. This is a double displacement reaction, but we change the copper from aqueous solution now to a precipitate. We take this precipitate, which is still has some liquid, of course, in there with the water. We are going to heat the sample. When we heat it up, it's going to go through a decomposition reaction. It would lose water and it would change to black color copper oxide. Copper oxide then, and on the next reaction, we are going to dissolve the copper oxide with sulfuric acid, and it would generate copper sulfate and other, which is water in this case. Then copper sulfate, which is the aqueous blue color solution, when we add to it zinc, in this reaction, zinc is going to replace the copper. Copper will be reduced to copper metal. So we have the metal plus the metal ion reacting is a single displacement reaction. So this reaction is like an acid-base reaction or double displacement reaction. Some reactions can be classified as more than one type. Like combustion reaction is also oxidation reduction reactions. So you would perform all these reactions in different steps following the procedure. You watch the video how it's done. You are going to learn about the different type of reactions, and you are going to also learn about the techniques like filtration, drying the sample with the heating lamp. Drying, sample or heating up the solution using like the setup with the Bunsen burner to boil the sample. So you learn a lot of washing, decanting, and filtration, of course. So you would learn about all those techniques, and you also learn about different type of reactions, which is a repeating of what I already said. Pay attention to what are all the products that you are getting. So when we use the copper hydroxide or you're using the copper nitrate, you add sodium hydroxide, you get copper hydroxide, you also get sodium nitrate. So pay attention to all. At the end of the experiment, when you get the copper recovered, you dry that copper using a heating lamp. You measure the mass, and that is known as the mass of recovered copper. And you have the initial mass of copper. Let's say if I use the 0.5 gram, then I would have the 0.15 gram here. That would be the mass of the copper. And then multiply by 100. That gives the percent recovery. This percent recovery, it should be 100%. That is going to be following the law for conservation of mass. But is it going to be 100% all the time? Maybe not, because if you don't add enough zinc here, not all of the copper is going to be reduced. If you add enough zinc, but you don't wait long enough, you would have some blue color solution. That means the copper has not been recovered. If you add too much zinc, you would get zinc mixed with copper. So the mass could be higher or it could be lower. I just use this reaction as an example. It could be the same thing in this case. When you add sodium hydroxide, if you don't add enough sodium hydroxide, some of the copper would stay in the solution. It doesn't precipitate because we need the hydroxide ion to change the copper to precipitate of copper hydroxide. So it would stay in the solution, and yet then you decant it. So that would cause loss of copper. So you may or may not get 100% recovery. But it's a good experiment because you learn a lot about techniques and different type of reactions.